of light. Pretty cool, huh? Speed of light. All right, so scientists say it's 186,000 miles per second. And they also say it's constant, right? So I say this is only partially true in the sense that, yeah, it might be at the speed at one instant in time, but generally speaking, it's not that speed. So let's go back a little bit here. Light, let's say this is a flashlight or a flame or a pretty light bulb. Let's make it a light bulb. So going like that, and you've got like that. And you've got a little thing burning in there, a little tungsten going on there. Got electricity flowing through there. So here's the light. All right, so the light travels at, let's just say for argument's sake, that it does go 186,000 miles per second. That means the light here, then you have 186,000 miles, the light will be there right away. So since we're like right here, then wow. So actually what happens, the most simplest form, is that the light starts to decay. It has a source. It comes from the source. The farther away it gets from the source, it starts to decay. It starts to break down. As it's no longer as dense here, it starts to spread out and decay. So it covers more area in the less amount of time. What we call when you cover more area of space in a less amount of time is faster. What that means is light, as it goes away from the source, goes faster. So it has an inversely relationship from the source. The farther away from the source, the faster it travels. However, as it decays and breaks down, you can't see it anymore or measure it anymore. So what? It just stops existing? No, of course not. Scientists say there's faster in light things like tachyons and neutrinos, and then they change their mind once in a while saying they don't exist, they thought they did, but it doesn't really matter because this light still exists, you just don't see it anymore because it's outside your visual range. It still exists. When you can't see light, you call it darkness. It doesn't mean that it's dark, it just means you don't see it with your eyes. So wire, electricity flows positive, negative. Electricity flows at 186. That's going to be constant because it's a constantly recreated condition. It's not really exactly 186,000 miles per second, but it's around there, practically speaking, that's what you can do. So what does that tell you? Why does it matter? E equals mc squared. Energy is equal to matter or mass times 186,000 squared. That's a big number. This basically tells you in a nuclear bomb that energy can be created. This is how much energy you get when you take whatever mass and multiply. But this is useless unless you have plutonium or cobalt or cesium or neutronium or whatever that stuff is, because no matter is unstable enough to make energy except these stuff. A lot of radiation, a lot of free radicals. You combine them with enough of each other and they become unstable and then they explode. Or they just convert matter into energy. It's like the reptile of matter, right? Reptiles, animals, plants, reptiles right in the middle. So same thing, plutonium is a reptile. You got solid mass, very stable, and then you got radiation and stuff, not really heavy. So there you go. Combine this enough, run some electricity or whatever through it, and then becomes unstable and blows up. So the other question is, if this is not constant, that means that all mathematical equations associated that depend on the speed of light being constant are wrong. So, theory of relativity, time travel, pretend I know what I'm doing because I'm a scientist. All those theories are wrong because there actually are no constants in the universe except change, right? So the only constant is there's no constants. But anyway, it doesn't really matter. Right now, all you have to know is the speed of light is not constant and it gets faster as you head away from its source. Are you wondering what it changes into? Are you wondering what happens to it? Well, I could tell you, but I don't really care to. So I'll talk to you later. Bye-bye.